Hello friends, welcome to Study Mac Education. Today we are going to discuss about MCQ for Mechanical Engineering Part 1. So let's start. Our first question is, sensible heat is the heat required to option A, change liquid into vapor, option B, increase the temperature of liquid or vapor, option C, none of the three mentioned here, option D, change vapor into liquid. Before select the correct answer, we should know what is the sensible heat, and there is also another heat, latent heat. So we must know the difference between latent heat and sensible heat. So let's see. Latent heat means phase change but temperature does not change. Remember, phase change but temperature does not change. In sensible heat, phase does not change but temperature will change. In sensible heat, phase does not change but temperature will change. So over here our option B is suitable because increase the temperature of liquid or vapor. So for sensible heat is the heat required to increase the temperature of liquid or vapor. Friends, here there are also some another important terms which is directly comes into the exam. So let's see. The term enthalpy. Enthalpy is basically denoted by capital H, and it is also known as thermal energy, and it is the product of internal energy, and it is the sum of internal energy and product of pressure and volume. H is equal to U plus pressure into volume. Next is specific heat. Specific heat means heat required by a substance to raise the temperature by 1 degree. Okay, specific heat means heat required by a substance to raise the temperature by 1 degree. Keep in mind. Next is an entropy, degradation of an energy. Yes, degradation word is very important. Exergy, an available energy, and energy, that is unavailable energy. These terms are very important for exam. Now move to our next question. Our next question is, ultrasonic machining is best suited for which material? Our option is A, hard and brittle, option B, porous, option C, none of the three mentioned here, option D, soft. Ultrasonic machining is basically use an abrasive material. An abrasive material for use for machining of glass, ceramic, etc. So our option is here hard and brittle. Let's see another important information. Over here EDM, ECM, USM, EBM and LBM. The machining rate of LBM, the material removal rate of LBM is very low in compared with electro discharge machining process. In laser beam machining, the material removing rate is very low. In electro beam machining process, this process take place into the vacuum, as we know, and ultrasonic machining process, which is use abrasive material for machining or to remove the material from workpiece. And for ECM, electrochemical machining, there is ion displacement take place, and it is also use electrolyte material. In electro discharge machining process, the material used is dielectric material. Keep remember, for EDM dielectric, for ECM electrolyte, for USM abrasive, and for EBM vacuum is required, and for laser the material removal rate is very low, and the highest material removal rate process is plasma machining. Remember. So here we are discuss about material removal rate. So let's discuss the material removal rate in drilling process and turning process, which is very important for exam point of view, for short numerical questions, etc. So let's discuss material removal rate in drilling. Material removal rate, the equation is pi by 4 d square or pi r square into F into n mm³ per minute. Unit is very important. The machining time, it depends upon the length of the hole to be drilled to the speed n and feed of the drill. The machining time is denoted by T is equal to L by F into N, and the unit is minute. Well, another equation is cutting condition in drilling. We have discussed about drilling right now. The cutting speed V is equal to pi into D into N. V is equal to pi d N, where D is equal to diameter of the drill in mm and N is equal to speed of the rotation in RPM. Feed rate F is the movement of the drill along the axis RPM. Depth of cut D is equal to the distance from the machine surface to the drill axis. D is equal to D by 2. So we have to remember all these equations for exam point of view. Now let's discuss for turning process. This is our workpiece. If you look from right side, then the rotation of workpiece is anti-clockwise, and this is the sided portion is our single point cutting tool. Now material removing rate V into F into D, where F is the feed and D is the depth in mm and feed is mm per revolution. The distance traveled by tool per one revolution. Okay, so I think this information is enough for MCQ. Now let's move to the next question. A stud, option A, has both the end threaded, has a head on one end and a nut fitted to the other, requires locking nuts, has pointed threads. So first of all we should know what is stud. This is the example of stud. As we can see, both the ends are threaded. So our option A is a stud has both the ends threaded. Our A is our right answer. At right side we can see the figure of turnbuckle. There is also some MCQ right directly from the turnbuckle, that turnbuckle has two ends. One end has left hand side thread and another side has right hand side thread. Keep in mind, if one side has left hand side, then another side has right hand side thread. Okay, so this is the turnbuckle and this is our stud. Now let's move to the next question. Very important question. The iron carbon diagram and the T time, temperature and transformation curves are determined under option A non-equilibrium and equilibrium condition respectively, option B equilibrium both, option D non-equilibrium both, and option D obviously none of the above. So our right answer is equilibrium both. Keep in mind. Friends, we will discuss iron carbon alloy phase diagram in brief in our next further videos, and also time, temperature, transformation diagram. But right now we have to discuss the important terms which are related very from which the questions are frequently come into the exam. So let's understand. Steel means if the carbon percentage in iron carbon alloy is 0 to 1.7, then it is known as steel. If the carbon percentage in iron carbon alloy is above 1.7, then it is known as cast iron. Okay, now there is also another diagram, time, temperature, transformation, which is related to austenite, martensite, bainite, pearlite, the transformation of these phases. So right now let's discuss the important data. What is the dead steel? Dead steel means up to 0.15% carbon. What is the carbon percentage in low carbon or mild steel? Remember, low carbon is also known as mild steel, and the carbon percentage is 0.15 to 0.45 percentage. Okay, now in a medium carbon steel the carbon percentage is 0.45 percentage to 0.8 percentage carbon. In high carbon steel the carbon percentage is 0.8 to 1.5 percentage carbon, and above 1.7 steel will convert into cast iron, and below 1.7 it will remain steel. Okay, for steel up to 1.7 carbon, well, that we know, and above 1.7 carbon the iron carbon alloy called cast iron. Yes, if steels contain 0.8 percentage carbon are known as eutectoid. Remember this word eutectoid. Steel which contain perlite, perlite is a phase. If steel contain less than 0.8 percentage carbon are known as hypoeutectoid. If less than hypoeutectoid, and if more than 0.8 percentage, then it is known as hypereutectoid. Eutectoid, hypoeutectoid and hypereutectoid. Well, in case of hypoeutectoid, steel which contain ferrite and perlite, and in case of hypereutectoid, steel contain cementite and perlite. In cementite contains 93.33 percentage iron and 6.67 percentage carbon for specifically cementite. In case of perlite consists 87 percentage ferrite and 13 percentage cementite. As you know, cementite has 93.33 percentage iron and 6.67 percentage carbon. Next point, if the iron carbon alloy contain 4.3 percentage carbon called eutectic cast iron. Keep in mind, before eutectic we have studied that if 0.8 percentage carbon, then it is known as eutectoid. If 4.3 percentage carbon, then it will known as eutectic. So don't confuse between eutectic and eutectoid. Let's discuss another information regarding this iron carbon. If the iron carbon alloy contain less than 4.3 percentage carbon called hypoeutectic cast iron. If the iron carbon alloy contains more than 4.3 carbon called hypereutectic cast iron. Okay, so don't confuse in between eutectoid and eutectic. Okay, so let's discuss new question. Well, the automobile radiator is the heat exchanger of counterflow, cross flow, none of the three mentioned here, and parallel flow. So our answer is cross flow type heat exchanger. Actually, heat exchanger are regenerative and recuperative type heat exchanger, but for exam point of view, for MCQ purpose, the types of heat exchanger are shown as below as per flow. So let's see. In this figure, the cold water inlet direction is A and cold water outlet direction at the point B. At this point C, our hot medium will inlet into the pipe and it will come out from point D. So that is our hot medium. This is our hot medium inlet, and this point D will be our hot medium outlet. So basically, as we can see here, the direction of cold water and the direction of cold water and the direction of hot medium are same, so it is known as parallel flow. And as we can see in the next figure, this is our heat exchanger tube. From hot medium is traveling in this direction, and the cold water is entering from point B and it will out from point A. So the direction of cold water and hot medium are different, or we can say opposite. So the type of heat exchanger is counter flow, And another important heat exchanger is known as cross flow type heat exchanger. As we can see in this vision, the hot medium is passing through the heat exchanger tube, and this is the cross flow of cold water inlet and outlet. So this is known as cross flow heat exchanger. It is very easy to understand. Now the important equations from which there are so many little MCQ numerical asked in exam, competitive exam. So let me explain that topic. Efficiency of heat exchanger, very important. Efficiency of heat exchanger, or epsilon, yes, the equation is hot medium inlet minus hot medium outlet divided by hot medium inlet minus cold medium inlet. So let's discuss this equation from the figure. Okay, let me clear all this. Well, as we can see in this spectacular vision, our equation shows that temperature of hot medium inlet minus temperature of hot medium outlet, okay, hot medium inlet and hot medium outlet, divided by temperature of hot medium inlet minus temperature of cold water inlet. Yes, cold water inlet from this. So as we can see here, the temperature of hot medium, the difference of temperature of hot medium inlet and outlet, and the temperature difference of hot medium inlet minus the temperature of cold water inlet. Okay, clear. Well, now next term is effectiveness of heat exchanger. Before effectiveness we have discussed already the efficiency of heat exchanger. So don't confuse between efficiency and effectiveness of heat exchanger. Both are different. First of all, effectiveness, Q by Q max means actual heat transfer divided by maximum possible heat transfer. Let me write again. Actual heat transfer divided by maximum possible heat transfer. Okay, over here we can see the heat capacity ratio, the another important term. It is defined as the ratio of minimum specific heat to the maximum specific heat. Another important term, number of transfer unit, as we know, and the equation is number of transfer unit U into A divided by minimum specific heat. Our U is the overall heat transfer, A is the area, C means minimum specific heat. Now the number of transfer unit NTU method is used to calculate the rate of the heat transfer in, very important, keep in mind, in heat exchanger, especially counter current flow exchanger, heat exchanger. Remember, number of transfer unit method is specially for counter current heat exchanger. So let's see which is the counter current heat exchanger. Over here we can see the flow of cold water and the medium is different. This is our hot medium traveling path, and this is the cold water traveling path. Both are opposite in nature. So this is the counter flow heat exchanger. Now another important term, degree of approach. Well, degree of approach in heat exchanger. We have seen effectiveness of heat exchanger. We have also seen efficiency of heat exchanger. So keep in mind efficiency of heat exchanger, effectiveness of heat exchanger, and the degree of approach in heat exchanger. It is defined as the temperature difference between temperature of hot medium outlet minus temperature of cold water outlet. I repeat, temperature of hot medium outlet, temperature of hot medium outlet minus temperature of cold cold water outlet. So let's see in the diagram. Over here we can see the temperature of hot medium outlet, this one, minus temperature of cold water outlet. Okay, this is our what degree of approach. This is our degree of approach in heat exchanger. Okay, now let's move to the next question. Size of boiler tube is specified by inside diameter thickness, outside diameter and thickness, outside diameter alone and mean diameter and thickness. So our answer is C, outside diameter alone. You have to remember this answer. Friends, wherever the important information that I have to inform you, I will show you in this video. So let's continue. Next question. Which is a device for holding and locating component for a specific operation and also guide the tool? Please read this question very carefully. What is the information given in the question? Which is device holding and locating component for specific component and also guide the tools? So our option is clamp, fixture, none of the three mentioned here, and jig. First of all, let me explain what is the jigs and fixture, the basic difference. The shaded area portion which is our workpiece, and this is our base, and this portion is our clamp. Okay, now over here we can see the workpiece is available only and the clamp is holding the workpiece only. So this is the example of fixture, keep in mind. And in below figure there is also a tool. Here the tool is drilling tool, and this shaded portion is our workpiece, and this is our clamp. This is also base and clamp, both are combined. So in this figure, this device is working or performing a job that to locate the tool and also guide the workpiece. So both function in one unit. So this type is known as jig. Jig is a device which, as per our question, jig is a device which holding, locating component specific operation and also guide the tool. So our right answer over here is jig. Okay, now let's go to next question. Stress concentration is caused due to, our option is pitting at a point or area at which loads on a member are applied. Next, B, abrupt change of section. Option C, all of the three mentioned here. And option D, variation in property of material from point to point in a member. To explain what is the meaning of stress concentration, let's see one example. This is one type of right angle piece. So as we can see, it is not exactly right angle. There is some variation. So before applying load, this specimen is right angle. So our end A is a fixed and end B is a free. Over here we can select the material MS, stainless steel, cast iron, whatever. If we applied a load up to 1000 Newton approximate at point B at the end, free end, now the fiber available which are away from these edges have less stress concentration in these areas, but at this edge of fiber the stress concentration are the means this portion have to deal with maximum amount of stress concentration. If you are using any simulation software like ANSYS or any other SolidWorks, so in that case we can directly see the stress concentration at this portion, because there is a abrupt change in section. There is also material change as we can explain in our later videos. Our option is splitting at a point or areas at which load on a member are applied. Next option, abrupt change of section, C, all of the above, and D, variation in properties of material from point to point in a member. So over here all the options are seems to be correct. So our option C, all of the three mentioned here, means A, B and D, all of the above are right. Okay, next question. Well, enthalpy, yes, H is equal to U plus PV, kilojoule per kg, which is the unit, and it is denoted by H, and specific enthalpy denoted by small h. Okay, let's come to the question. Enthalpy remain constant in condenser, evaporator, throttling, and all the three mentioned here. Well, our answer is throttling. So let's discuss what is condenser and evaporator. So here we have one spectacular vision in which this portion is our room and this is our wall, and this inside unit of air conditioning is known as evaporator, and this is outside unit, and this unit is known as condenser, and condenser has compressor inbuilt in nowadays. So enthalpy remains constant in throttling process. Another term which is entropy. For entropy you have to remember entropy is zero in reversible adiabatic process. Okay, remember entropy means capital S is zero in reversible adiabatic process. Now another term, throttling is the irreversible thermodynamic process, and free expansion of the gas or fluid for this process is also known as irreversible process. Means free expansion and throttling both are irreversible process, and remaining all other processes are reversible. Keep in mind. So for irreversible throttling and free expansion process, the work done and heat exchange are zero. I repeat, work done and heat exchange are zero. Now let's go to the new question. Okay, PERT, PERT, very well known term. PERT stand for option A, planning, evaluation and reporting technique. Option B, process, evaluation and review reporting technique. Option C, planning, estimation and review technique. Option D, project, evaluation and review technique. Friends, these all options are wrong, because the right full form of PERT is program, evaluation and review technique. I repeat, program, evaluation and review technique. This is the right full form of PERT. So sometimes it will happen in exam that all options are given in the question are wrong. Keep in mind. Now friends, this is the end of the video, and we will continue uploading the new videos, so to be continued. And press like button if you like this video, to be very frank, and also give comments, because your feedbacks are very important and valuable for us. Share this video with your engineering friends like mechanical, automobile and mechatronics, etc. And don't forget to subscribe this channel to join with us for next video. Please subscribe this channel. We are also available on Facebook, Twitter, LinkedIn, Google+. If you have any query or any suggestion, yes, if you have any query and any suggestion, then you are feel free to contact us on email studymagaeducation@gmail.com. Thank you. Goodbye.